Grace, did you accidentally nick yourself again?
Alright. So, we started with 4 over 5 minus x. We want to get this in the form a over 1 minus r. The big thing to note is in this formula, there are only 2 requirements. You have to have a 1 and you have to have a minus sign. Right? This can be anything, this can be anything, this has to be a 1, this has to be a minus sign. So if we divide top and bottom by 5, we end up with 4/5 over 1 minus x over 5. That's our a, that's our r. Now if you think about the sum as n goes from 0 to infinity of a times r to the n, geometric series, we know that this sum is a over 1 minus r. So what we're doing next is we're going to start with the sum and back into the series. Alright? So, we've always started with the series and figured out the sum. Now we're going to start with the sum and back into the geometric series. So, we rewrite using sigma notation, and we get 4/5 times x over 5 to the n. Oh, by the way, here's a little hint. Make sure on your test, right? Make sure you are starting from 0 when you're finding a sum, right? All right, just let you know. Okay. This and this are equivalent. To get from here to here, I just took this 5 to the n and combined it with the other 5 and made it a 5 to the n plus 1. This way is written more as a geometric series, and this way is written more as a traditional power series. Power series, remember, you have a sub n x to the times x to the n. Whereas a geometric series, you have a times r to the n. The geometric form is going to be more useful today than the power series form. So we're going to stick today with the geometric form, and that's what we're going to do for the next couple days. Yes, question?
Couldn't you also just make Rx minus 4?
You do 4 over 1 minus x minus 4, the whole.
Wait.
So 5 minus in parentheses x minus 4.
No, 1 minus.
Or sorry, yeah, 1 minus in parentheses x minus 4. Because let that be the
That's the
same.
same.
But then, oh, wait.
So 4 over 1 minus.
Yeah, but then, okay, yeah, you could do that. You could. It would be a very different series.
Yeah,
A different
Yeah.
set.
4 times x minus 4 to the n.
Yeah, that's
Yeah.
way easier.
I it's just funny easier, right? And then when you have to like expand it, it's
Yeah, when you expand it,
do
it's
less
the same
math.
thing every time.
It's really like
Okay, I will tell you that for what,
You can do that.
you can high five all you want, but for what we're doing today, you're gonna have to do it this way.
Oh,
Yeah, this is what we're gonna be looking for.
so we did it wrong?
no, we did it right, Chris. The book is wrong. The book is wrong.
No, Dylan.
And your test.
And the text.
Okay.
Calculus.
Calculus.
What about the AP test?
Hey,
Oh my God.
And the exam. I don't know, that's very, it's when you just, your tactic is going to prove useful in just a moment.
yeah, it is.
Okay, yeah, it is, right? Okay, and the way that you'll know for sure, where there won't be any question as to what to do, is we will in the future have to give you a center. So if this said centered at 0, then you'd be out of luck, right? Because yours would be centered at 4.
We could do
What is
it
that?
x minus 4 minus c.
Yeah. Alright, so then to write as a polynomial, all you're doing is plugging in values for n, right? And you get it as a polynomial. Okay, this polynomial is called the geometric power series for the function because it is based on the sum of geometric series.
Miss Price, he did something
Oh,
wrong.
and by the way, this should be a 6.
Yeah.
Sorry. That's a righto. Good. Is that okay?
Should we
Yeah.
write down this polynomial part?
Alright, good. So let's get into the lesson today. Oh, someone asked me how to do homework problem number 47, so I put it up there. One of the things, and I'll go ahead and say this on video, one of the things that I will tell you the thing that troubled this student was not so much finding the derivative or finding the integral, or even finding, using the ratio test and finding the radius and initial interval of convergence. It was plugging in the endpoints and doing all the different tests that had to be done to evaluate the endpoints for convergence. Your test, the first 8 problems, we give you a series and you have to decide if it converges or diverges, and you have to back it up, right, with some math. I'm just gonna say this right now, I don't mind telling Mr. Thomas I said this. There is not a single one where it is just an obvious p-test or an obvious geometric series. There is not a single one where it's just obvious, okay?
Why do you do this?
What do you do this to me?
So,
Mr. Thomas, not her.
here's,
Don't blame him, he just can't.
it's okay, I teach with him, I take responsibility as well, I'm in full support of the test, right? So, anyway, here's what you should know. You need to know your convergence tests really, really well, right? Because there will be problems where you'll look at it and you're gonna have to try multiple tests before you finally get one that works, right? So, yes?
What is the test?
Good question. When is the test? It is not on Friday.
Next Thursday.
Next
It is
Monday.
not on Thursday.
Monday.
Not
Wait,
this Monday, but
Friday.
the following.
Oh, if it's fixed Monday,
It's
I'm out.
fixed, it's on the website, it's updated, I changed it up.
It's
Wait,
not
hold on.
this Monday,
It's on
but
Monday,
it's the
actually.
next, isn't
Wait.
it?
This test, the test is on Monday, as in next week.
Next to next
It's
Monday.
listed on, or
Few weeks,
the last time we
right.
talked about it was on.
I don't, okay, I'm just gonna stop.
Pet Fest.
Oh, that's awesome, I love having one.
Reyes,
We
Yeah, we have
the
to
culmination
do
of
it
Not this Friday, the next.
because we're a day ahead.
Solid
Oh, that's better.
I forgot.
We're gonna be all.
I don't know anything.
I think you had 2 tests.
Here's what we
One for
found
the
out.
first time,
Yeah, no.
and then one for
Found
the
out
second.
Friday, March 25th is a Pet Fest. And because it is a Pet Fest, all the periods are shorter. And therefore we cannot test on that day. Your test has 20 problems on it. It's a
Thank you,
big
Kyle.
test.
champion this
So,
year.
Thank you.
I don't have to
because
show
of
up.
this,
We're doing
the
that
test
Thursday.
is now moved to the following Monday, which means you get 1, 2, 3, 4 days
It's a terrible day to have tests on Mondays because the entire.
Wait, and the weekend.
No, we can't have a Tuesday,
and the
but we
weekend.
can't have so we can not have a Monday, but we can't have a Tuesday either, but we can't have a Friday.
What you're
Something's
really
on
saying
Wednesday.
is you don't want us to be ready for the AP exam. That's what you're saying.
No,
Stop! Why are you trying to compare our
As a matter
performance?
of fact,
Guys, just because you only care about the AP doesn't mean
Dylan, shut up.
quiet down, quiet down.
Ryan, let me
As a
hear
matter of
it.
fact,
Yeah.
because we're losing another day, I'm actually thinking about condensing
That means we're gonna go from like a 5
10-1
to a
down to
4.
1 day to make up for it.
What?
10-1 is all review. It is
So I can teach
parabolas, ellipses, hyperbolas,
Oh.
what's the center, where are the foci?
Miss Price, why do you do this to us?
And I'm back in this class.
Yeah, good, good.
She's like all the way back to geometry.
So we have a test
I'll
with
do
Derek.
it.
We're not gonna have a test, so anyway, moving on.
Just try to get.
No, is it?
Yeah, last one.
We're real mechanics and stuff.
Okay, so representing, quiet down.
Gets rid of it.
Representing functions with power series. So today what we're going to do is we're going to be able to find geometric power series, and then we're going to be able to construct a power series using series operations. We will be learning how to add and subtract and, well, today just add and subtract, but later on we'll be doing all kinds of other stuff too. Okay. So it begins with this one, and I'm going to leave this up there because I'm going to refer to it in a minute, but you can ignore it right now. So we're going back to the warm-up problem, 4 over 5 minus x. The power series that we found to represent this function that we found was centered at 0, right? Okay. What if we wanted to represent the same function, but we wanted to center it at c equals -2? So if we want to center it at c equals -2, the first thing that you want to do is replace your x with an x minus c, so an x minus -2,
So what we did was.
right? If you, it was to be centered at 4, right? Okay, yes. So, what we're gonna do is we're gonna replace the x with an x plus 2. So you end up with 4 over 5 minus the quantity x plus 2. But you can't just go around adding 2, right? So we have to balance it out. It's kind of like when you complete the square, right? If you add 4, you have to subtract 4 kind of a thing, right? But you have to pay attention to your coefficient. So make sure if there's a negative, you distribute it, and then think about what you have to add appropriately to balance it. So I want you to take a second and come up with your new function if you modify this so that it's centered at -2.
You just add 2.
Make sure you're adding -2.
Oh god, no. Isn't 3 minus?
Where they, it's no way you're adding like
Oh, 7
even
minus
soap or whatever, and they pick up balls.
Just add it.
And then don't be as a
Oh,
red face, I
yeah,
think that's the way, I think that's the way.
Stop it!
You take away all
Stop
of the mystery
believing-
and
Yeah.
just potatoes to distribute it, and you still manage to not
It's
distribute it.
okay.
Alright,
But
so.
you actually did it.
So when we replace our x with an x plus 2, there's a minus in front, so you're actually subtracting 2, so we have to add 2 to balance it, right? Yeah. So you end up, sorry, so you end up with 7 minus quantity x plus 2. We need this to be in the form a over 1 minus r.
She divides by 7.
Now we gotta divide top and bottom by 7. Go ahead and do that. Divide top and bottom by 7.
Minus over 7. Oh god, we need some water. Or traumatic event.
Yes, of course.
Wait, Will.
Like dopey or whatever, because like soap.
Oh yeah,
When you like soap or whatever, and you pick up the bubbles.
So anyway, okay, so you end up with, gentlemen, you end up with 4.
Oh.
So you end up with 4 7s over 1 minus x plus 2 over 7. Everyone comfortable with that?
Yes.
Okay, so your a is,
4 7ths.
and your r is,
X plus 2, the whole over 7.
write it with sigma.
Nah. We've been with that.
Can't really.
I'm a literate.
But he's math literate.
I am.
You just can't.
No, we just straight up
Can't write letters.
Once you get that, I want you to take, oh, actually don't yet. Just stop there. Everyone have their sigma?
That's weird.
Okay, this form is great. This is fine. This is fine too, but this will be easier to use for what we're doing next. So when I started doing these problems on my own, I just went ahead and defaulted to the ratio test, like I always do for my radius and interval of convergence. And then I started noticing, my goodness, every time I do these, I'm just getting r, absolute, is less than 1. And then I thought, it's just geometric. Why am I not just doing geometric series tests for all of these when they are geometric series, right? Geometric series says that the geometric series will converge if absolute value of r is less than 1. So when you are testing or finding your interval of convergence for this, all you have to do is set the absolute value of r less than 1. And you can skip all the rest of it because this is going to be the conclusion every time anyway, because they are geometric, right? Now, have we found the radius yet?
No.
What is the radius?
7.
How'd you get 7?
You gotta get rid of the 7.
Got to multiply both sides by 7. Does everyone understand that? Because you have to have absolute x minus c, right? Less than r.
I'm just gonna say yes.
Is that okay? Okay. So you end up with absolute x plus 2 is less than 7, so your radius is 7. And then if you write it out and then subtract the 2, you get negative, your interval, your beginning interval is -9 to 5. Here's the thing about geometric series. If it really is geometric, the endpoints will always diverge. Because what'll happen is every time you plug these numbers in, you're going to get an actual -1 to the end, or you're gonna get number times -1 to the end, or number times 1 to the end, and it will always fail the nth term test. So, because of that, I'm still testing the endpoints every single time because I'm just so not comfortable not testing them. But I will tell you that the endpoints will always diverge when it's geometric. If it's truly geometric, then the endpoints will diverge.
Geometric?
I'm just not comfortable enough. I haven't done enough to like convince myself that that is always true. But so far, it's always
The
true.
book has it like that too.
Does it really?
It's like one of the justifications for the answers, it says, the endpoints, diverge because geometric.
Oh, well, okay, I'm feeling better then. Okay, I'm a little more comfortable. But, yeah, so it's always gonna be the open interval if it's truly geometric and you don't even have to. You know why I'm kind of uncomfortable? Because I've been going through Mr. Thomas's notes and I've been going through Miss Johnson's notes, and both of them on every single problem, including these, wrote the words, test the end points, with like little exclamation points, right? So that, it makes me nervous not to, when they're both like doing that, so. Anyway, okay. Are there any questions? Are you kind of feeling what we're doing?
So, I mean, if we do a geometric thingamabob, when we do it like geometrically, we don't have to test, right?
Are you sure? Yeah. Okay, you had a look of fear in your
No, I
face.
see.
Yes, Brian, I didn't hear you.
Oh, sorry, I'll repeat myself again. So if something is like geometric, you don't have to test the endpoints. You can just say that they diverge, right? Or do you?
I'm gonna go with okay on that.
I'll take that as a yes.
Okay.
There's gonna be something pretend
So-
geometric.
Why is
I know, that's the only thing that worries me is like something's gonna come up where that's not true,
I
but
will take my chance.
you're gonna
You
take
come
your
up on the
chances.
test,
Okay, then
or,
it's-
like, we good.
don't test at your own risk, alright?
Okay.
Okay. Alright, yes, sorry.
I have a question about those 2 study days that we have, like on Thursday and Friday. Are we gonna like start a new like thing then, or are we just gonna review only?
Mr. Thomas and I have to discuss it.
Okay.
We just review.
Why don't we just
Yeah.
review?
I think we should.
Why don't we do
His
that?
class is a day behind,
Yeah.
so
Yeah.
they don't have 4 days, they have 3. And he did say that he traditionally gives 3 review days for this test. So, he will probably not move ahead and teach new material.
We get 3 review days and 1 day to just ask.
No. We should have a movie day.
No, here's what I actually think I'm gonna do. I thought about doing something fun for review, but then I thought instead about keeping a serious, obviously the first day is the big quiz, right? It always is.
Oh, God.
Is that when we
Second day
individual?
is always going over the big quiz. But I'm thinking on the third day of making like a practice test that you take in class.
So another
Like play some
And so,
Jeopardy or something.
yeah, so
Basically
basically,
the
yeah, it
quiz.
would be a quiz, but without, like, not open note, nothing, just
Oh, yeah, at least
pencil
learn.
and
Yeah.
nothing else.
Yeah, I like that.
And then,
Or
and then
you know what
kind
you
of
could've
going
done?
over those
You
questions.
could have just not told us about this whole scenario and told us that the test would be on that day. And then when we take it and fail it, you'd be like,
Let's practice
So 5
No one would be even funnier, Tommy.
absurdly hard to do.
Finding out that the beginning is a practice test.
5 minutes before the period ends, just, hey guys, I got something to tell you, and just like, drop the bomb.
Okay, I did something like that before, which I'll tell you about someday,
Oh,
but not right now.
no, come
she's
on.
gonna do it to us. She's like, I told you about it.
Okay, so anyway, here's what I want you guys to do. We have 4 over 3x plus 2. We need to write this as a power series centered at x equals positive 2. Alright? Not negative 2, but positive 2. Then find the radius interval of convergence. So when it's positive 2, you have to replace the x with an x minus 2. Always start first by replacing x with x minus c, whatever your center is, right? So we end up with replacing it with an x minus 2 and then figure out what you have to add or subtract to balance it out, right? Then you might have to do some rearranging and some dividing, all that kind of stuff. 1 minus, yes.
Two,
Wait,
there are.
what?
Negative. Lord.
1 minus minus.
And that
His name is Trey.
yes,
Dude, mine too.
yes, okay.
Haha.
Hey, what'd you
So
say
that
that
was
was?
something, a lot of people got
I
stuck.
said
What
his
was
name
my
is.
name?
I said his name is Trey.
Trey's?
Trays.
Trays?
I know about tray.
Gentlemen, please, just work. Take a minute or two and just work on problem.
The blonder.
Adrian.
Oh, don't distribute, but I mean like, think about what you want to find out, you have to have them in three square. Okay, okay, good, so you got the 8. So now, do you think it would be like 8 words so that you can have it? Good. So say you've got something on the bottom that's, oh, I don't know, something like 8 plus x's and stuff, right? And we need something more like 8 minus x's and stuff. So how could we change a plus to a minus? Yeah, make it minus negative, right? So, yeah, it's okay. Change the plus to a minus negative and just have a negative coefficient on with your r.
That's beautiful.
It is beautiful.
That's such a good. That's the best word.
I have. That is a very good, and yet very sad movie, yes, yes. Very good.
Life is beautiful.
I've never seen it, but when
Oh,
the movie makes
you
you cry.
really should watch it.
It's so good. It's
You blame
hilarious.
it? I
Yeah,
was
it's-
bawling the entire time. That's a little baby.
And he has a little
Yeah, kind of. It's
Or
like a
internment.
oh,
boy,
I've never seen similar.
and the boy doesn't know what's going on.
Oh, yeah, no, I
How
remember.
the man is being treated, and he tries to make the boy like think it's all happy, like they're almost like they're just at camp or whatever. And it's really good.
Yeah, I think
I think it's more, doesn't have subtitles on it?
Or the second
It got an Oscar though, doesn't it?
Really good.
Okay, I just watched that. It was so good.
So anyway, yes, I,
wasn't
once
bad,
again,
but, like,
on topic.
it was
So,
bad.
although that was dummy, I just did it through, but still it's great. Okay, so
Especially so I was
getting
really
us
happy
back on topic. Back on topic. Okay, so, did you all get this? And then you put the 8 in front, right? But you need a minus. So you make it 8 minus negative, right? And that's how you take care of the needing to be a minus. Then you divide everything by 8. So you end up with 1/2 over 1 minus negative 3/8 times x minus 2. Keep the x minus 2, don't distribute in, right? Always have x minus c as its own little term. So now you have your sum, a times r to the n. And you can keep it just like that. You can multiply it out. This would be more in kind of a traditional power series form, but this is geometric series, and this one's going to be really easy then to find the radius and
So
interval.
when you want to find like, when you want to find the r value, do you have to get rid of any like coefficients in front of x? Like 3, okay.
Oh, wait, you're talking about the radius?
Yeah.
No, I thought you were talking about the r here.
No,
No,
the
the
radius.
radius, yes. The
Okay.
radius has to be absolute x minus c less than number.
Okay.
Yes, yes, very good question. So I'm going to take a second now, if you haven't already done so, and find the radius and the interval of convergence.
You gotta change the sign here. Because you're not finding that negative.
No, because you take the absolute value.
Oh, Do we need to change, does it does matter? Yeah, that's what I thought. It still matters.
You're saving 3 times.
So you get this, and then you have, by the way, does the negative matter?
No.
No, as a matter of fact, whenever you are doing these tests, the first thing I want you to do is drop that negative. Don't start distributing it in, because when you take an absolute value, it's gonna vanish anyway, right? So ignore the negative, just think about the 3/8, multiply by 8/3, so you end up with a radius of 8/3, and then your interval of convergence is from negative 2/3 to 14/3. I chose to test the endpoints, they both diverged. So you end up with a final interval of negative 2/3 to 14/3. Yep. Okay. How are you feeling about these? About writing them in the a over 1 minus r form? Okay, let's try another one. Good. Whoa. Okay, so we're going to take it up a little notch. Okay, I am going to give you a nudge. Okay? Okay, thank you. Suppose h of x is x over x squared minus 1. Find a power series for h of x centered at 0. Then determine the interval of convergence. So it doesn't matter what a and r are. They just have to be of the form a over 1 minus r. So, is there something simple we could do to make this of the form a over 1 minus r?
Times it by
Take out the x squared.
I would just multiply top and bottom by negative 1. Why don't we do that and see what happens? And then I want you to write it as a series.
No.
Why you want to? Why would you want to?
There you go.
No more. Oh, so 1 minus x squared.
Oh.
Come on.
Yes. A can be anything.
Yes.
Yes.
2. That's 6.
Miss Rice?
Yes.
No,
Yeah, beautiful.
can you just combine everything, or is it better?
You
not?
could, but I wouldn't, because when you test it on the R.
Oh, right, you wanna find the thingamabob.
Yes.
I am a very eloquent person, thank you very much.
Right.
No.
It's so He's like gulping it out for 9 minutes.
Alright, so you multiply top and bottom by negative 1, you get negative x over 1 minus x squared. There's your a, there's your r. So you have a times r to the n. It's okay that there are x's. So you still have the exact same, did you ever do the radius and interval? No, couldn't do it. I'll give you a minute. You're correct. Yeah. You would have an x squared, yeah. When you have x squared is less than 1, then you take the square root of whatever numbers you put on each side. You measure it, just put it on what's your inside here. Yeah, so you have value of the r is less than 1. From this to this. Oh, if you, this is the same as x to the 2n, right? Okay, x times x to the 2n, when you multiply, you add your exponents. So x to the first times x to the 2n is actually just 1. And then the negative just sketch it out. But this is fine. This is actually better because this one now you have your r clear cut, so you can do your test. So when you do absolute value of x squared, is that the same thing as x squared?
Yes.
Yes.
X squared is always going to be positive.
Of course.
Yes.
Yes.
Okay. Now I did the whole ratio test because I wasn't convinced that this was truly geometric. But the more I do, the more I realize, you know what? When we're talking about the series, x really does just represent numbers. So it's still geometric. And you can still do the geometric series test. I went ahead and did the ratio test just because I wasn't comfortable. I'm very uncomfortable. As the years go by, I will become more comfortable. But before I am super comfortable, I'm doing like overkill on tests to make sure. So, but then I did end up with just the geometric series test anyway. So there we go. Absolute value of x squared is the same thing as x squared. We keep getting these ones, but I want you to understand, just so you know how to deal with an x squared, if you have an x squared less than something like 9, you take the square root, whoops, negative and positive, and put the x in between, all right? Do you understand that?
Yep.
Okay, so here, the x squared is just less than 1, so we're back to our same old negative 1 to 1 thing like we always have. And test the endpoints, and look at that, they both diverge again, and you're still with the open interval that you want. Alright. Yes?
Sorry, can you explain again how it was geometric from the?
Oh, this?
Yeah.
Okay, because technically, when we have a series, our input isn't x, our input is n. X represents numbers. And technically, has to be in this interval for that series to converge. So x is any number between -1 and 1 that you feel like plugging in. So really, if you think about it, say x is a half, then we'd have -1/2 times 1/4 to the n. And so we end up, it's still geometric because x just represents numbers. You still have a times r to the n.
Okay, but like, how did you know to test x squared? Or
Because this is your, when you have a whole geometric series, a times r to the n, right? So that's your a, that's your r.
Oh, okay.
Yeah. Good, good. Other questions before we move on? Yes.
So if the series is like kind of like a function of x, why does it change when like x changes? Like what is the function we're looking at that describes the change in like the changing series essentially?
I'm trying to think of what you're asking. Are you asking if we wrote it in polynomial form?
I guess kind of like my question is
In
like why?
polynomial form, your input is x, right?
Yeah.
In series form, your input is n. If we write the series as a function, like f of x equals that series, then you get a new function for each n.
Okay.
It's kind of a, it's a whole different thing, depending on how you look at it. Actually, there's just one function, because it's the sum,
Oh, okay.
right? That's an important distinction, right? It's the sum. So, yeah, so if I called this f of x, then my input to my function would be x, and it would be this, after I plug all the n's in, then I would have something that was just in terms of x. If I keep it like this, then x has to be, I'd have to plug in numbers for x, and I get different sums depending on which numbers I plugged in for x. And x can be any number between -1 and x for it to converge to a sum. Moving on. Okay.
That's where.
Now, this part, if I didn't have your attention before, which I had it fairly good, this part we can't get off
It says locked.
on tangents because this part really takes some thought. Alright? You ready for thinking?
No. It doesn't matter.
Let's have our thinking caps on. Alright, audience out there. So, close attention and really follow. Listen to me step by step. I will lead you through. Once we get through the first one, which may feel overwhelming, I will show it to you again, and it will feel easier. Okay? All right, everything's hard the first time you do it, then it gets easier. Here's what's going to happen with these types of problems. You are going to be given an opening series. In this case, we're told, hey, 1 plus x is equal to this series. There's a lot of series that we already know. And like when you get to 9, 10, there's this huge page, it's just a giant list of series, right? So if you take a function and convert it to sigma notation, like what we just did with all the past functions, right? Use that a over 1 minus r thing and rewrite it in sigma form. That's what this is, right? So there's tons of these, and it's not just 1 over 1 plus x, right? You could do it with e to the x, you could do it with sine x, you could do it with arctan x, right? There's all kinds of ways that you can take a function and convert it to a series. Here, what's going to happen is we're going to be given a series that we know, something simple that we did using the a over 1 minus r technique, and we're going to use this to rewrite a more complicated function using sigma notation. All right? Okay, so we are going to start with nothing but this, and from this, we are going to come up with a series for that.
So it's kind of the thing that you're talking with like engineers, how they don't have an exact function, but they try to approximate it with
Yes.
Okay.
I really don't know that yet, but I think so. So, all right. I think so. It's all right, yes.
Like we need just that.
So anyway, all right, so let's start with f of x, right? We've got this natural log of 1 minus x squared. Somehow, we have to make this relate to this.
Derivative.
Yeah.
Kind of. Before we take the derivative, can we simplify the log in some way?
Yes.
How could we?
You split it up into 1 minus x and 1 plus x.
We factor the argument, right?
Then you split up and add
So
2.
this is 1 plus x times 1 minus x, right? When we are multiplying the argument of a log, we can write it as a sum of logs. Are you all with me? Good. Everyone okay so far? All right. Now, I see a 1 plus x here, and I see a 1 plus x there.
Derivative.
Way. Integrate.
There you go. And you, both of you.
Yeah, because you
Are
take the
correct.
derivative of the first one, you integrate the second.
If you differentiate this guy, you get that. Which means if you integrate this guy, you get that, right? We don't know a sigma form for this, but we do know a sigma form for that. So we have to kind of start with this. I worked with this a little bit just so I could kind of see how they relate, but really this needs to drive it. So, because this is what I have the sigma for. So rather than writing a derivative of this plus a derivative of that, I'm going to write an integral of 1 plus x plus an integral of 1 minus x. Please forgive me for writing a plus c because we hadn't integrated yet. There shouldn't be a c there. Now, so I have an integral of 1 plus x plus an integral of 1 minus x to get each of these. Now, I don't actually have plus an integral of 1 minus x. I have minus an integral of 1 over 1 minus x. Why do I have minus 1 over 1 minus x?
Because you want to take out the negative.
The guts are negative. The derivative guts are negative.
Yes, yes. Because if I were to take the derivative of natural log 1 minus x, it wouldn't just be 1 over 1 minus x, it'd be negative 1 over 1 minus x, right? So in order to back into this, I have to have a negative in front. Do you understand what I'm saying? Okay. Everyone okay with why the negative is there? All right, good. All right, so do y'all agree now? We've just decided that this equals this, which equals that. We good so far? equals this.
So you can just write it as a one.
So you just integrate the power center.
Alright? So, what we're gonna do then is, first, I know that that is that, right? I need to use this as my basis to come up with a signal form for this guy. It's really actually very easy. So if if I have this as my sum for 1 over 1 plus x, if I just change the x to a negative x, which it is, in my sum, then I get this guy. Now, I wish when I had done this that I had written the intervening step. Let me just make sure you understand what the intervening step was. If for this one, if I change the x to a negative x, I get negative 1 to the n, negative x to the n.
Oh, you can take a negative out.
Negative 1 to the n times negative x to the n is just x to the n. That, I'm not pulling a negative 1 out. Why is this negative here? It's because of that guy, right? That's that one, right? This is negative 1 times negative x just equals x. Tell me if you're with me or not.
Yeah.
You need to make sure, bless you, need to make sure you understand that if you have something similar to this, but it's just a little different, just modify your formula to accommodate it. So if this was 1, even if it's something like really different, like say I have 1 over 1 plus 3x squared, right? You can go to your formula and replace the x with a 3x squared. Alright, do you understand? Okay.
This is kind of. Oh no, I think he's strung out.
Okay, I want to make sure everyone's okay. You're decent? Okay. Alright, so now here's what we have. We have that the natural log of 1 minus x squared is equal to the natural log of 1 plus x plus the natural log of 1 minus x, which is equal to the integral of 1 over 1 plus x minus the integral of 1 over 1 minus x. So now this integral becomes the integral of this sum minus the integral of that sum.
What does it mean to take the
How does that help us?
Yeah, actually.
Now we have to integrate the sums. Hey, it's a good thing on Monday we learned how to integrate series,
Did we?
Yeah, you just
did.
integrate it on normal.
right?
Oh yeah,
So-
with respect to x. and
So all you have to do to integrate the series is integrate with respect to x. Nothing else, everything else is just a big coefficient. I want you to take a second and actually integrate each of these. Don't forget your plus c's.
Plus c is.
Well, like plus 6, 6.
Good one. Plus c is. But you can always add in the 6, 6, 6. Just be like 6. Because it's like, you can always change the
They could say 6, 6, negative 1 to the because if you had.
Yeah, you could just divide it by 6,
Exactly.
6, 6.
I'm telling you, you could do that. I wrote down like 6.239 repeating pi plus c on what
Yeah,
that's
not.
We wrote cubes next to it. It's like cube.
Just think if you had to integrate x to the 5th, right? So
Oh.
x to the 6 over 6.
Oh,
So the integral of x
do you want to check what I got?
This one.
There's a monkey side, by the way.
Everything else just stays.
I just got this view of
Everything else just stays. The negative 1 to the end is just a coefficient. So you just raise it by 1 and divide by the negative, right?
And I was like,
Wait, did we already say C is 0?
No, C is
Can I hear something, or am I just not?
no, my plus C.
Yeah, I figured.
Oh, the center? Yeah, because we asked for it to be centered in
Whoa.
zero.
Otherwise we would have to say like
Whoa.
Yeah.
I'll go farther, right?
Yeah, that was a little.
Okay,
Yeah.
good.
You don't know
Yes,
how to
Tori.
target, huh?
Can you all be quiet, please?
Can you show it integrating the first, like, set?
Sure. So whenever you're integrating a series, all you're looking at is your x term. Nothing else is relevant. So whenever you have x to a power, you just raise the power by 1 and divide by the power. Everything else that's there just comes along. Think of it as a coefficient. So this one, same thing. Just raise the power by 1 and divide by the power.
But isn't n like changing?
No, think of just n as just being a number. We're only differentiating with, or integrating with respect to x.
Okay.
So treat n as just a constant. All right, so we've got this lovely series, sum of series now, but we have a c. You have to solve for c. Whoops. Okay,
Classic.
so to solve for c, you can plug any number in, because you have an equation here, and then solve for c.
Classic.
I would plug in 0 every time. Because if you, well, whatever your center is what you want to plug in, because then this will go to 0 and this will go to 0.
Oh, World Cup. Wait, you're doing.
So, to solve for c, you get natural log of 1 equals 0 minus 0 plus c.
Sick.
Just pick a number for x and plug it in. I would plug in 0. You always want to plug in your center. Because what happens is, it doesn't matter what anything else is, you're going to be multiplying it by 0 to the end.
Oh, and then you can not really get it. Your socks are polo.
There's just put 1 c for all of the constants.
What are your shoes? Those are sick. What are your shoes? They're sick.
What's natural log of 1?
0.
0. So our c